This next paper, as many people predicted, is going to be on COVID transmission in the air in outdoor and indoor environments and the implication for airborne transmission. So does COVID exist in the air? Yes, 73 of 77 papers detected COVID in the air. Contamination of surfaces was more frequent than air, but with a lower positivity rate. We'll cover this in detail later. And then the highest concentration areas of COVID are indoors in the hospital, followed by indoors in general, followed by public places where lots of people are, followed by the outdoors. So there are two main sources of respiratory droplets. This is direct transmission through aerosols, fine aerosols, and then indirect transmission through larger respiratory droplets that would be on surfaces. These can happen during coughs, sneezes, during breathing itself, which is respiration, speaking, singing, and shouting. For the aerosolized particles, these are particles less than 5 micrometers in diameter, so smaller than that size. They can remain suspended in the air for a period. Now, interestingly, from several studies above, in these cumulative studies, 60.3% of air samples tested were positive for COVID, and surface samples that were tested had about a 90% positivity rate, meaning that COVID is more frequently found on surfaces rather than in the air. And in 15 studies in which air samples tested negative, there were trace amounts of COVID found on different surfaces. So this is the word I want you to remember. It's fomites. This is when a virus contaminates a surface, like a material, like a desk or something like that, or even your pet. So this indirect transmission can occur by touching these surfaces, followed by touching the mouth, nose, or eyes. And the authors are noting that the difference between air and surface samples could originate from several factors. So one factor is that surfaces could be contaminated also by direct contact from infected individuals, like if they coughed in their hand and then wiped it somewhere, not just from respiratory aerosolized particles. And the second factor is that these virus-laden particles, as we saw in the previous study, the deposits are relatively large, which could have a different viral load compared to the ultrafine particles, the very small particles that were in the air. Now, two major things that impact the air sampling quality is the distance from the infection source, as well as the flow rate of the air. For example, the air 1 meter from a patient, the positivity rate of infection was about 94.4%, but at 3 meters distance, this decreased to 22.2% for a positivity rate. So that's the difference between 3 feet versus about 9 feet. So importantly, physical distancing from people that are infected with COVID dramatically reduces the risk of airborne transmission. Additionally, high airflow is going to push the particles away, so it makes the particles less concentrated, the particles of COVID, that is. So if you're in a very windy barn, for instance, or a very windy place, then your likelihood of being infected with COVID becomes nearly negligible. Next, something that needs to be standardized is the amount of air that's being sampled, because the studies all do different things. For instance, these are 3 different sampling volumes, so you have a smaller one to a larger one, and from the small to the large, they, in the same area, they go from about a 28% sampling positivity to a 55% sampling positivity in the larger area. So this is something that should be considered for studies. This is just a fun science fact. And also from all of the data they looked at, the average positivity rate in air was about 22.8%, while the average positivity rate from surfaces was about 12.4%. However, if all of the air samples are considered together as a single data set, the positivity rate would be around 13.3% against the 10% for the surface area samples, or the surface samples taken, suggesting that the positivity rate in the surface samples could be more similar to what we'd get from air infection. Due to inconsistencies between studies and the low sample size that you collect of virus particles from air samples versus surface samples, they had inconclusive viability if the virus that they found positive for COVID could actually be infectious. That's something that will have to be explored in other papers. It was just inconclusive from what they looked at here. However, it is important to note that contamination from COVID is more frequently found on surfaces rather than in air samples, which is something that has also been observed in hospitals and healthcare settings.